Not a problem. So yes, my name is Dirk Cairns-Gallimore. I'm the Federal Program Manager at DOE headquarters for the Advanced Manufacturing portfolio. And so today, briefly, I'm just going to go over what we're interested in for our 2021 call. So the vision for the Advanced Manufacturing Program is to improve and demonstrate the methods by which nuclear equipment, components, and plants are manufactured, fabricated, assembled, and utilizing state-of-the-art methods. This can vary from additive manufacturing for metals all the way through some advanced formations for concrete and other activities associated with the plant. And the goal is to accelerate the innovations to reduce costs and schedules for these new plants and constructions, and really to make them just more effective and easier for us to deal with as we move to a much more broad power portfolio. We go into the fabrication of nuclear power plants, of course, is faster, less expensive, and more reliable. And to make sure that our quality is also included in that. So the AMM has quite a few focus areas, from factory and field fabrication techniques, modular manufacturing, processes, and inspections. As you can see, we have several different areas. And for this year, we are really going to be focusing on the modular manufacturing and the new advanced manufacturing technologies for qualification and certification to accelerate licensing. And this is actually one of our areas that we're looking at as a critical need. So our technical areas for NEET-1, our 1.1 is the modular advanced manufacturing approaches. So this is prefabrication and pre-assembly approaches for manufacturing technologies that can dramatically improve competitiveness of new reactors and lines. We're seeking proposals that enhance the economics and the flexibility of advanced manufacturing technologies, developing mature technologies that can facilitate modular designs and constructions, enhancing of modular manufacturing technologies, including decreased necessity of field modifications. And an example of this is the emerging powder metallurgy techniques for fabricating nuclear components. This can offer many benefits, including parts consolidation, reducing requirements for field fabrication and welding, and also the potential for replacement of forging or pressure vessels. One of the other key things that we're also looking for for modular construction is for replacement parts as well. So that we can have multiple parts and look into different ways of replacing aging and challenging parts. The other section is 1.2, which is the new advanced manufacturing technologies for qualification and certification. Major opportunities for this AM process and digital workflows to develop and support validation and qualification to move beyond code case approvals. We are looking to develop and utilize enabling technologies through a combination of fabrication and modeling and digital analysis to allow designers and manufacturers and supply chain to interact and to enable an increased data accuracy and accelerate qualification of a final product. Specific attention to lessons learned from other industries as justification for some of our proposed approaches. This will be crucial for success as we move forward. And we know that there's other aerospace industries and other that are currently using advanced manufacturing technologies, including additive manufacturing for critical parts and supplies. So we know that we should be able to leverage some of those lessons learned from those industries and apply them to here. Granted, we are in a nuclear realm and we understand that there are challenges and differences, but they have a lot of direct experience that we need to be leveraging. Developing the new digital thread and digital twin visualization and planning technologies is also included in this. This is going to be critical for our parts qualification and certification as we move forward. This is an area where we can really see some advances, both when the parts are manufactured and in the as-built condition, meaning when they come off the line, they can be certified for use. And proposals focusing on specific aspects for qualification or licensing approaches clearly justify future integration for a complete strategy. This is important for our applicants to understand, is that we're not just looking for the technology, but how it fits into the strategy and how it's going to be part of the supply chain itself. And then for the NSUF-1.2, our technical focus area for that is going to be the irradiation testing of advanced manufacturing materials and components to demonstrate performance. As the specific radiation effects on the fabrication parameters will be considered. What we're trying to understand here is looking at how our fabrication technologies and techniques and what happens when we vary the parameters to get more grain structures or other conditions that are advantageous to our designs. And we want to understand if that has effect on their actual radiation and radiation effects performance. The funds to support the preparation and analysis of the materials and samples, but we're not looking, this is not funding advanced research into new materials. So we are looking at existing materials as much as possible. And so kind of a summary of our expectations, the technologies developed will decrease the cost of manufacturing and the fabrication of components and piece parts for the nuclear power plants, or to improve the cost and schedule for construction times. We're looking to develop the development of products and components that will be able to gain acceptance by the appropriate regulatory or standard setting bodies. This is the critical area of qualification and certification. And along those lines is that once we have that robust structure in place, we have specific products that could be capable of being deployed commercially in a nuclear power plant. And I think that's kind of the focus of where AMM is going. We're looking at the technologies. We're wanting to see how the certification and process gaps we can accelerate and move those into the field deployment, and then that they are readily able to be deployed in a commercial environment. And so like I said, my name is Dirk Cairns-Gallimore. I'm the Federal Project Manager. And then my technical point of contact is Isabella Van Rooyen at INL. And I will gladly take any questions if there are any.
Thanks, Dirk. Let me check and see if Isabella is on the call. I see her here. I'll unmute her so she can answer questions as well. Isabella, you'll need to unmute your own mic. We will take questions through the question and answer box on the GoToWebinar meeting app over the next few minutes. So if you do have questions, please submit them there and we will relay them. First question, Isabella, did you get your mic on?
Yes.
Okay, perfect. For NEET 1.2, do you have any specific materials in mind? Is a new material okay?
Dirk, are you taking the question?
Yeah, I can take that question. So are new materials okay? I think new materials are acceptable as long as we can see the traceability to an end use. I think that's one of the factors that we need to be considering when we're looking at our applications, is tying it to the concept where it's going to be used, so we can see that it flows into the supply chain.
For NSUF 1.2, is ion irradiation an attractive option, or is neutron irradiation a must?
I personally prefer neutron irradiation, unless the proposal can specifically provide the leap or the direct comparison between the results found in ion irradiation and what the effect will be as part of the neutron irradiation. But preferably, if ion irradiation is used, to be used as an interim step until the neutron irradiation, for down selection for neutron irradiation components.
We'll continue to accept questions over the next minute or two. Please do submit them if you have them. some additional questions for NSUF 1.2. This is a follow-up from the first question. Can you give some specific examples of existing materials? Dirk, you may be muted.
Okay, I'm on. Actually, I think I'd like to hand that question off to Isabella for that one.
I think I missed the question. Can you please repeat?
Yeah, for NSUF 1.2, are there specific existing materials that you have in mind?
No. We do not want to limit it to a specific material. It is for the PIs to describe and justify why they would like to look at that material. But as Dirk presented, it is really not only to do an evaluation for the science sake. The science must be concluded or be approached with the end purpose in mind and the end application in mind. That will make it more attractive.
Is a modeling component allowed in NSUF 1.2?
Dirk, please verify for me, but according to me, I do not think so. It is more applicable to the NEET goals.
I believe that's correct.
Is concrete 3D printing of interest?
Yes, it is. We have seen some applications in the past for 3D printing, and I think I'd have to go back. I think we have looked. Yes, it is. I can't speak on some of our prior awards, but I believe we've had some on for advanced forming for concrete. So yes, we are interested in that as well.
Yeah, and it may be applicable also to the NEET portion of the modularity, but don't let me be too prescriptive.
Is mesoscale computational modeling of the microstructures of 3D printed parts of interest?
If you put it into context of one of the NEET application, or again, it comes down to the justification of why you want to do it and how it is going to accelerate qualification or the irradiation knowledge of changes in the microstructure, then it will be relevant because it is one of the advanced methods for manufacturing.
Or NEET 1.2, is this only for additive manufacturing processes?
Definitely no. Advanced methods for manufacturing is very cross-cutting amongst a large variety of fabrication processes. So we are specifically interested in other methods as well. How can we improve current processes that is out there to accelerate the work and to make the work more reliable? Maybe Dirk, you want to add there?
No, I think you summed it up very well, Isabel. It is not just limited to additive manufacturing. We are looking. I mean, if there's some even significant changes that improve forging technology would be even acceptable in this area as well.
Are there any specific modeling capabilities that are of interest for this NEET workscope?
No, we are not prescriptive on the modeling methods to be used.
Okay, those are all the questions we have. We will wait for one more minute. We're still within our time frame, so please do add in any questions if you have them right now. Is a collaboration with a national lab, Oak Ridge or INL encouraged?
Your team members and collaborators need to make sense in regards to the work scope and the justification. As Dirk said during the presentation and in some of the answers, it is important to have an end goal in mind. So therefore, make sure that your full package of collaborators are each contributing to the end objectives.
For NEET 1.2, as a forging application, do you have a specific material or materials in mind?
Materials that would be those that are relevant to our current, fleet or of advanced reactor materials. Those are ones we have the most interest in. But we're not specifying specific materials because there's quite a few that are being used or are in consideration for use.
For NSUF 1.2, will advanced fuels be considered?
Dirk, maybe you can help here, please.
Let me take that question and get back to those individuals, because that'll require some coordination between a couple of offices, depending on what their application is.
Yes.
So I'm not going to say no, but I'm also not necessarily going to say yes right now either.
So we'll pursue a clarification to that question, and we will post the response at a later date. Okay, those appear to be all the questions. Thank you, Dirk. Thank you, Isabella.